Welcome to the deep dive. Today we're really getting into something critical, global education. Because let's face it, if you're trying to learn new skills, or maybe you're a student looking at tuition fees, the current system feels, well, strained. We've gathered a whole stack of material here looking into what one company is calling a potential solution, the third way of learning. And we're not just talking small tweaks. The sources we've looked at suggest education really needs a kind of Henry Ford moment, something revolutionary in scale, speed, and cost. Our mission today is to figure out if this new virtual campus launch from EON Reality actually delivers on that huge promise.
That's really the core question, isn't it? Is this a genuine paradigm shift or just clever marketing? We need to break down how this third way supposedly weaves together three major technologies: AI mentors, immersive XR environments, and really rapid course generation. The goal, they state, is making education truly universal, accessible, and, well, instant.
Okay, so let's set the scene a bit. To really get the third way, we probably need to understand the first two ways first.
Right.
Because they had benefits, but also created some serious bottlenecks, especially now.
Definitely. So the first way, that's the traditional physical campus, the universities, the colleges we all know. Historically, its strengths are pretty clear. That direct human connection, instructors, classmates, and, proper hands-on learning in labs, those are real advantages. But the weaknesses, they've become almost crippling today. First, the cost. Building and running physical campuses, specialized labs, it's incredibly expensive.
And that cost gets passed right down to the learner, to you.
Exactly. And second, the speed, or lack of it. Developing new programs, updating curricula, it takes years. Way too slow for today's job market.
Right. The world changes faster than the syllabus. So then came the internet, trying to fix the speed and access problem. That led to the second way.
A second way, yeah, that's traditional online learning. Think MOOCs, video lectures, PDFs. And it did solve some big problems. Suddenly, geography wasn't a barrier. Costs came down. You could theoretically access great content from anywhere.
There's always a but.
There is. The huge failing was engagement. And frankly, effectiveness for practical skills. Trying to learn complex hands-on stuff just by watching videos, it doesn't really stick for most people.
Yeah, you see those terrible completion rates for MOOCs, sometimes, below 10%?
Exactly. Single digits often. It solved scale, maybe, but created this huge gap in actual engagement and proving competency. You can read about welding, but you don't learn to weld until you try it.
Which brings us neatly to this EON virtual campus, the proposed third way. It aims to blend the best of both worlds, right? The structure and hands-on feel of the first way with the scale and accessibility of the second way. And those early claims about completion rates jumping up are, well, they're attention-grabbing.
They are. Much higher than the MROC model, according to their reports.
Okay, let's get under the hood then. If this system is meant to deliver that hands-on, personalized experience at scale, what are the key parts making it tick?
It really starts with the AI layer. They call their AI avatars Brainy. Think of Brainy as your personal tutor, available 24/7. But, crucially, it has memory, institutional memory about you.
Okay, so it's not like starting over every single time you log in.
No, exactly. It remembers your progress, where you struggled, what you've mastered. So if you say, failed a quiz on aerodynamics last week, Brainy knows. This week, it won't just give you the same quiz. It might integrate role-playing scenarios or specific feedback targeting why you failed last time.
That role-playing part sounds really interesting, especially for skills that aren't just technical, things like communication or handling difficult situations.
Precisely. You could run through a simulated crisis scenario, Brainy could play the upset customer, or maybe a difficult team member you need to persuade. It allows practice for those crucial soft skills.
But that brings up a question, obviously. If Brainy remembers everything, what about privacy? How is all that learner data handled, especially now?
That's a critical point, and they seem to address it directly in the materials. The architecture is designed, apparently, to keep individual learner data siloed and secure. They talk about advanced encryption and ensuring the data is only used to personalize your learning path, not for other purposes. Privacy is paramount if this is going to be trusted.
Definitely a necessary assurance. Okay, so Brainy handles the guidance, the soft skills practice. Where does the hands-on part come in? Where do you actually, fix the virtual engine or practice the medical procedure?
That's the next layer. The immersive XR labs and simulations. XR meaning extended reality, covering virtual and augmented reality. And this is the big break from just watching videos. Here, you are the one performing the task. You're manipulating detailed 3D models of equipment. Maybe it's repairing a complex machine, practicing a delicate nursing procedure, assembling something new, but all in a completely safe virtual space. No real-world risk.
Right. It's the difference between reading the instructions and actually doing the assembly. But again, accessibility comes to mind. When people hear XR, they often think of, expensive headsets. Is that a requirement here?
That's a really common concern and, yeah, vital for a global solution. The sources emphasize that the design is deliberately mobile first. So the experience is optimized for smartphones, which, let's face it, billions of people already have.
Okay.
A headset might give you, like, the peak immersion, sure, but the core interactive lessons, the 3D models, the simulations, they say, it all works on standard low-cost devices.
What about places with spotty internet? Does that kill the experience?
They've apparently thought about that too. The platform is built to work in low bandwidth situations, and critically, it allows for offline access. You can download modules when you do have connectivity, then work through them later.
Yeah.
That's huge for bridging the digital divide in many parts of the world.
Okay, so the pieces seem to be there. Personalized AI guidance, immersive practice labs, and broad accessibility. But that leads to the next massive question. Content.
Oh.
How do you create enough high-quality immersive content fast enough to meet global demand, especially for rapid reskilling?
Ah, yes. This is where we get to what might be the most disruptive part of the whole thing, course genius. Think about traditional course development. The sources we looked at consistently put the timeline at, 6 to 9 months per course? Maybe longer.
Yeah, designing, writing, creating visuals, labs. It's a huge effort, usually involving big teams.
Exactly. Course Genius uses AI to automate almost all of that. And the claim here is, well, it's pretty staggering. They say a full course chapters, lessons, quizzes, and those interactive XR labs can be generated in around 100 seconds.
Whoa, hold on. 100 seconds for a full course. That sounds almost too good to be true. Doesn't that just scream fast food education? Where's the quality control, the pedagogical thought?
It's a natural reaction, absolutely. And they seem aware of that skepticism. The explanation is that the AI isn't just inventing things randomly. It's designed to ingest existing verified knowledge, like textbooks, institutional materials, industry standards, and then it automatically generates the instructional structure, the quizzes, and crucially, the XR interactive elements based on that validated data.
Okay, so the speed is in the assembly and the instructional design, not necessarily embedding the core information itself.
That seems to be the idea. The AI builds the learning experience around trusted content.
If that holds up, the implication isn't just making a few courses quicker, it's potentially shifting education from being like a scarce resource to something more like a utility, abundant on demand, like electricity.
That's exactly the analogy they lean towards. And the scale numbers reflect that. They talk about being able to generate, say, 9 or 10,000 courses over a single weekend.
10,000 courses,
Yeah.
the potential impact on workforce training, national reskilling efforts. It's immense if it works.
Immense. And the rollout plan they describe follows that logic. First, a huge generic library of pre-built courses. Then, localization adapting courses not just for language, but for specific local industries, cultural contexts. And finally, institutional co-creation. This allows a university or a company to take the Course Genius engine and instantly embed their own proprietary knowledge, their branding, into that rapid generation framework.
And for the individual learner, the really exciting bit seems to be the on-demand aspect. Like if I realize I need a quick refresher on, a specific aspect of supply chain logistics,
Yeah.
I could theoretically ask Brainy to create a short, focused course just on that, right there and then.
That's the promise. A specialized course, generated instantly, complete with XR practice elements, tailored just for you, just when you need it. It's the ultimate vision of personalized, just-in-time learning.
Okay, this all sounds incredibly powerful. But now we hit the really crucial point for anyone hiring or certifying credibility. If courses can be spun up this fast, how do we trust the quality? And more importantly, how do you actually verify someone has learned something?
Right, the assessment piece is critical, and it requires a completely different approach than traditional methods. If learning is instant and immersive, assessment needs to match. So the shift is away from multiple choice tests, away from just recalling facts. It moves almost entirely to simulation-based assessment, meaning the system evaluates you based on performance within the XR environment. Doesn't just ask you about safety rules, it tracks whether you actually perform the correct safety procedure on the virtual machine, maybe under pressure.
I see. So the grading is automated, but based on demonstrated action, on motor skills, on decision-making within the simulation itself.
Exactly. Did you diagnose the virtual patient correctly? Did you assemble the virtual engine following the right steps in the right order? The assessment is embedded in the doing.
So the certificate you get at the end isn't just proof you sat through videos.
No.
It's evidence that you successfully did the thing, validated by the system's tracking.
That's the goal. And to make those credentials trusted globally, they talk about the EON Integrity Suite. These certificates are designed to be secure, verifiable, maybe through QR codes or even blockchain integration, and importantly, resistant to cheating, because you can't really cheat performing a complex task in a monitored simulation. And they're actively working, according to the sources, to align these certifications with international standards, bodies like UNESCO and the OECD, to ensure employers everywhere recognize their value.
Let's circle back to those outcome numbers you mentioned earlier, those high retention rates, like 70–80% compared to MOOCs. Where does that data come from? Is it just small, early tests or something more sustained?
The reports suggest it's from sustained pilot programs run globally across different types of institutions, vocational schools, universities.
And what do they pin that success on? Why are people sticking with it?
Two main things consistently. One, the experiential learning by doing. When you actively practice something, especially in an immersive way, it just sticks better, retention goes up. And two, the personalized help from Brainy. If the system adapts when you're struggling, provides targeted feedback, you're much less likely to get frustrated and just drop out.
That makes intuitive sense. Less frustration, more progress, higher completion. And the other big outcome claim was speed, faster time to competency.
Yes, they're reporting significant reductions there too, maybe 50 to 70% faster to reach proficiency compared to traditional classroom or online methods in some pilots.
And the economic knock-on effect of that is obvious.
Absolutely.
Yeah.
If you can reskill workers for, say, new green energy jobs in 3 months instead of 9 or 12, that's a massive boost for individuals and the economy. It creates a much more direct line from learning a skill to getting a job and earning an income.
Okay, but let's talk about the elephant in the room, the existing education system. If this technology is potentially so much faster, cheaper, and maybe even more effective for certain skills, it seems like a direct threat to the traditional university model, especially their often slow and, let's be honest, quite lucrative course creation process.
That's undeniably the major hurdle, isn't it? Institutional inertia and perhaps even resistance.
So how do they plan to overcome that?
Yeah.
How do you convince institutions to adopt something that could fundamentally disrupt their business model?
It seems the strategy isn't necessarily to replace institutions, but to position this as a tool for them, a tool for modernization, maybe even survival. They're likely targeting the pain points institutions already feel: the high cost of physical labs, the struggle to keep curricula up to date, the difficulty in scaling specialized training. By offering that co-creation model, the pitch might be: use Course Genius to rapidly handle, say, 80% of your foundational or generic course updates. That frees up your expert faculty to focus on the high-value 20%, the cutting-edge research, the deep mentorship, the critical thinking discussions that humans do best.
So it's framed as an upgrade, a way to stay relevant in a world demanding faster knowledge transfer.
Exactly. A necessary tool to compete globally, rather than an outright replacement. Whether institutions will buy into that vision remains to be seen, of course.
Looking back at everything we've discussed, it seems this third way, if it lives up to the claims, isn't just about putting VR headsets on people. It's about fundamentally tackling those core bottlenecks that have plagued education for decades. The cost, the time it takes, the geographical limitations, all at once.
That's the synthesis, yes. Trying to make education scalable like the internet, but immersive and effective like hands-on practice, and intelligent through AI personalization.
That Model T analogy you mentioned earlier keeps coming back to me.
It's a powerful one they use. Henry Ford didn't invent the automobile, but he made it accessible. He put it within reach of the average person through mass production and lower costs. The ambition here seems similar for knowledge. Can the virtual campus make high-quality, specialized, practical education truly universal, deeply immersive, and almost instantly available?
A profound potential shift in who gets to learn what and when.
It really is. And maybe here's a final thought to leave with you, the learner, listening to this. For so long, education has been about choosing from a menu, a curriculum designed by an institution, often for a kind of average student. But now, think about what happens if course generation becomes truly instant and personalized. Consider how this might empower you. You might move from just being a selector of courses to becoming, in a way, the architect of your own learning pathway, able to shape, refine, and even instantly create the precise knowledge you need exactly when you need it, directly aligned with your career goals or curiosities. That's a fundamental shift in agency for the learner.